Hello, everyone. So today we're going to do the graphs of tangent, cotangent, also secant and cosecant. So last class we did sine and cosine. And if you remember from that lesson, what I tried to do was shorten it up, even though it was super long still, where we went through the transformations and then I showed you the graph, not just make it in front of you. So that saved some time. So I'm going to try to do that today to help us out. So let A and B be the coordinates of points on the unit circle. For any given angle x, t of x is b over a. This means that y equals tan x is undefined whenever a is 0, right? Because we can't divide by 0. For any angle x, given angle x, cotangent equals a over b, right? We do that reciprocal. So that means that y equals cotangent x is undefined where b is 0. Notice that it takes pi radians for the values of tangent and cotangent to make one complete cycle. So remember that for one complete cycle for sine and cosine, it was 2 pi, but for tangent and cotangent, it's going to be pi. So the domain of x or y equals tangent x is a set of all real numbers except of the form pi over 2 plus k pi, where k is an integer and the equation of the vertical asymptotes are x equals pi over 2 plus k pi, where k is the integer, okay? So with our asymptotes this time, we're going to make sure that we write it in equation form so we capture all the asymptotes, okay? So let's talk about the parent function of tangent x and what we get in this period. So remember, the whole cycle, the period is pi, correct? But instead of going 0 to pi, so we can see that really big effect from asymptote to asymptote, we're going to go negative pi over 2 to pi over 2. So negative pi over 2, that would be our negative 1 over 0, which is undefined. Negative pi over 4 would be negative 1. 0 is 0. Pi over 4 is 1. And pi over 2 is our undefined. So we have our asymptotes. So now I'm going to show you the graph. Remember, I'm going to save time instead of graphing. So I have our asymptotes at negative pi over 2 and pi over 2. I plot my points. Now, even though it might look linear, it is not. It curves, right? Because we could do all these points in between and graph them out. And it gets almost this cubic sort of shape, okay? And of course, our lines or our function gets really close to the asymptote, just like that. All right, when graphing cotangent functions, of course, we're still the set of all real numbers, except for the form k pi, where k is an integer. The equation of the vertical asymptotes are x equals k pi, where k is an integer. Okay, so let's fill out this table. So we have undefined. Pi over 4 would be 1. Pi over 2 is 0. 3 pi over 4 is negative 1. And pi is undefined. Now again, it's still from a period of pi, right? But in this case, we're going from asymptote to asymptote. So it starts at 0, goes to pi. Now when we look at this graph, we look that, hey, it almost looks like tangent, but we're shifting it over and we're flipping the graph, right? So it kind of does a downward x cubed or negative x cubed, right? So we can still use the same approach to graph tangent and cotangent as we did sine and cosine. Okay, so we're still going to use our transformation. But the biggest point is when we talk about the period, it's not going to be 2 pi over b. It's going to be pi over b because that's our original period of where it starts repeating that cycle. Okay, so examples, what we're going to do is graph 2 full periods of each function and state the period and asymptotes. Okay, so we have x and y, and we're going to put down our parent function. So we've got tangent starts at negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. So we have undefined. We have negative 1, 0, 1, and undefined. Now, as you can see, the only thing we are doing to this graph is multiplying x by 1/2. So that's on the inside, we do it to x, and we have to do the opposite of what we're doing. So we have to multiply by 2. All right, if we multiply by 2, I get negative pi. Oops, there it goes. Pi, negative pi over 2, 0, pi over 2, and pi. Okay, so again, we have our pi, right? This is, we're doubling it, right? Because we are multiplying that. So here we go. We want to think of the period. Remember, this should be our period right here, this whole thing. So what is it? It is pi over b, which is 1/2, which when we simplify that, we get 2 pi. And what do you know? Even though this doesn't say 2 pi up here, we have pi, 2 pi. So that works. Now asymptotes. If you remember on the first page, it said pi over 2, right? So I guess I'm just looking back here for a second. It said pi over 2 because that's where the asymptote started, right? I'm going to show you right here. Pi over 2 plus k pi. Now, by the way, pi here is the period. Okay? And this is our asymptote, our positive asymptote. So this is how we would want to do it. For our asymptote, always go to the first positive asymptote, which in this case is pi. Okay, and then what we're going to do is add our period k. If we graph this, when we graph this, I should say, I'm going to graph this right now, and I'm going to graph 2 of them, right? So this is that first period that I graph from here, and then I continue. As I can see, with the asymptote being at pi, the next one should be at 3 pi. So does that make sense? If I put in 1 for k, do I get 3 pi? Yes, I do. Okay. We're adding a full period each time for our asymptote. So again, this will go quicker as we do our tables and our period asymptotes. Okay, so this is cotangent. So we start at 0, pi over 4, pi over 2, 3 pi over 4, and pi. All right, so we have here, we start at undefined. We get 1, 0, negative 1, 0. Okay, let's look what's happening here. On the outside here, we're multiplying by 2, so I have to multiply the y's by 2. Undefined, of course, stays undefined. We have 2, 0, negative 2, and, oh, this should be undefined. I don't know what I did there. Undefined stays. Now, on the inside, as you can see, we're going to have a phase shift, right? Now, we got to do the opposite, so we're going to go left, pi over 3. I'm not going to write it down that we have a phase shift. You'll see on my other answer key when I graph that we have a phase shift. But be careful of what the directions want. And the directions in this case was 2 periods. Tell me what the period in it is in the asymptote. So we get negative pi over 3. Then when we subtract, we get negative pi over 12. We get pi over 6. We get 5 pi over 12. And we get 2 pi over 3. Okay, again, I'm doing that math ahead of time. That's how fast I'm doing it, but watch your fractions. So period, our b in this case is 1, so our period is still pi. Okay. And then we get our asymptotes. Start at your first positive asymptote, which we have as 2 pi over 3. And we're going to add our period k. And that's how we get our asymptotes. Now I'm going to graph. Don't forget, this should be kind of on the down for the cotangent. And what do you know? Now the only thing is here, we're doing a vertical stretch of 2. So that's why we are not at 1 and -1. We moved over pi over 3. Okay. And to the left. So it was at 0 and now it's at negative pi over 3. And you can even double check all your asymptotes by saying, hey, if this is 1, do we get 5 pi over 3? Yes, we do. And we're all set. Okay, let's do the next one. So let's do our transformations. This is tangent, so negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2. We get undefined, -1, 0, 1, undefined. Okay, let's do our y stuff first. Remember why we have to do the multiplication, which we're multiplying by 3. We get undefined, -3, 0, 3, undefined. Then we're moving it up 1, right? This is a vertical shift. We're going to add 1 when we still have undefined. -2, 1, and 4, undefined. Okay, before we do what's happening to the x values here is what do we need to do here? We need to factor. So we have 2 times x plus pi fourths. Okay, remember what we're going to do is do our 2 first and then our pi fourths. So it's on the inside, so I'm going to multiply by 1/2. When I multiply by 1/2, I get negative pi over 4. We get negative pi over 8. We get 0, pi over 8, and pi over 4. Let's check with our period on there. So period, remember, is pi over b for tangent. So pi over 2. And what do you know? 1/4 and 1/4 is 1/2. Excuse me. Now on the inside, remember to go to your factored. We're going to do the opposite. So we're going to move left, which is subtraction, pi fourths. When we subtract here, we get negative pi over 2. We get negative 3 pi over 8. Negative pi fourths. Excuse me. We get negative pi over 8. And we get 0. Okay, let's check our asymptotes before we graph. So it's our first positive undefined, which in this case is 0, plus, and then we take our period, k. Now, of course, do you need that 0 there? No, you don't. And what do you know? I graph my first period, and I keep going with it. Let's see, I think we have one more before we go into secant and cosecant, and we want to double check on this stuff. So it's factored already, so that's great. So xy, this is cotangent, so 0, pi over 4, pi over 2, 3 pi over 4 and pi. So we have undefined, we have 1, 0, -1, undefined. Let's do our y step first, right? So we're going to multiply by 2 because there's that 2 up front. We don't call that an amplitude because tangent and cotangent, they don't have this hump that we can raise, right? It's just a vertical stretch. We're taking our function and we're stretching it out. So undefined, 2, 0, -2, undefined. And then, of course, we are moving this down a vertical shift by 1. So undefined, 1, 0, -3, undefined. My cursive's getting messy, guys. Let's do our x value as factors, so I don't have to worry about that, but I'm going to multiply this by 1/3. 0, pi over 12, pi over 6, 3 pi over 12, which is, no, not 3 pi over 12. Yep, 3 pi over 12, which is pi over 4. So let me just reduce that. And then pi over 3. Let's check our period because that's where that's supposed to come from, right? So our period is pi over b. And what do you know? Gives me that 1/3, 0 to 1/3, right? 0 to pi over 3, I should say. We're going right pi over 6. So I'm going to add these for you quickly. Pi over 6, pi over 4. Again, take that time to do those fractions if you need to. Practice those. So when you get to your assessment, you are quick on your toes with these. So that's 5 pi over 12. And this is pi over 2. Okay, let's check our asymptote. Start at your positive asymptote, which we can start at pi over 6. We're going to add our period. Okay. And let's see what our graph looks like now. Here's our first period from pi over 6 to pi over 12. As you can see, because I needed to do the second period, what I did is I changed these all into 12ths, so I knew the pattern. So we went 2, 3, 4, 5, 6, 7, 8, 9, 10. So I was able to see how many pies I'm adding. Now really you're adding a pi, right? Because that's a full period, but we're in 12, so changes everything a bit. But this is allows me to do my units very quickly. Okay. And that is what we have for cotangent and tangent. So let's see if we can get through our secant and cosecant quickly. So remember that secant is 1 over cosine and cosecant is 1 over sine. So since we aren't allowed to divide by 0, that means whenever cosine x is 0, secant is undefined. And whenever sine of x is 0, cosecant is undefined. So that means we have asymptotes here, right? So if we talk about just in our normal parent function, that one period, we can see that we have an asymptote for secant at pi over 2 and 3 pi over 2. Now, of course, those aren't the only asymptotes. I'm just talking about that first period that we look at for cosine. And for cosecant, that first period, of course, would be at 0, pi, and 2 pi. Okay, so that's going to help us fill out our parent function locations. So the graphs of y equals secant and y equals cosecant have vertical asymptotes in these locations. Of course, they keep going, right? So to find all of the asymptotes, what you want to do is, again, find the smallest non-negative where the function is undefined and add this value to k times the distance between the asymptotes. Now that means that we're not just doing it in one period. There's multiple asymptotes in one period. So I'm going to show you how that looks as we go along. So we are really going to be looking at, again, the transformations, but let's keep in mind the reciprocals. So I want to show you what cosine looked like again, and so what secant looks. So cosine was 1, 0, -1, 0, and 1. Okay, so that means when we do the reciprocal, we get 1 undefined, -1 undefined, and 1. Okay, now I'm going to show you how this looks. Remember, I graphed it already. I actually graphed cosine and secant so you can see what happens. So here's my cosine graph, okay, that wave. For every time it hits the x-axis, so where it was 0, we now, for secant, have an asymptote. So see how I have an asymptote right here? And then what happens is, because we're kind of flipping that, it's almost like this parabola, this upside down parabola now flips up. So the green is our secant. Now I want to show you the asymptotes really quickly. Now, when it comes to our period, right? Because we're talking about 2 pi, right? As you can see, I can go from -1/2 to 3 pi over 1/2. Okay. So if you see, we have 3 of these. So really, if our period is 2 pi, our asymptotes are actually a pi in between. So what we're going to do is take our period, what's given to us, divided by 2, and that's where the asymptotes break up. So again, if this is 2 pi, I see that there's an asymptote every pi. So I'm taking my period and dividing it by 2 for those asymptotes. This will get more familiar as we start graphing. Now let's talk about cosecant. Again, we're going to do the same thing. We're going to look at sine and see what happens with cosecant. So at sine, we have 0, 1, 0, -1, and 0. So when we do our reciprocal of cosecant here, we get undefined 1, undefined, -1, and undefined. So let's look at that graph. Same idea. Every time our sine hit the 0, excuse me guys, the x-axis, we have our asymptote. And then that reciprocal flips it, right? So we have our parabolas facing this way. Okay. So of course, when I graph the 1, I know in a cosecant, it's going to flip up, not down. Because if it goes down, it goes through the x-axis. And we know that it's supposed to be reciprocal, so we flip it. Okay, let's talk about asymptotes again. Again, our full period is 2 pi, but as you can see, I have an asymptote every pi. So again, for cosecant and secant, we are taking our period and dividing it in half and adding it on to that first positive asymptote. Okay. Okay, so let's try graphing some of these. Again, we need 2 full periods, period, and asymptotes. So x, y. Okay, secant, so we're going to go 0, pi over 2, pi, 3 pi over 4, and 2 pi, because we're doing a full period. So that means for secant, we have 1 undefined, because don't forget, we are doing secant. We're not doing cosine right now. -1, undefined, 1. Okay, for our y's, it looks like we're doing a vertical stretch here of 3. Sorry, guys, I had a moment, -3, undefined, and 3. Now on the inside here, we are going by 1/2, right? Because we do kind of the reciprocal there. So 0, pi over 4, pi over 2, 3 pi over 4, because I read, no, this should be over 2. That's why I was confused, guys. Did you catch that before I did? And this is pi. So it looks like my period is now pi. Let's check on that. So period. Now, because it's the reciprocal, we start out with the 2 pi and then over b, and our b in this case is 2. Reduce that, we get our period of pi. So that's great. Now, asymptotes. Remember what we said about secant and cosecant. Start with your first positive asymptote, which in this case is pi over 4. And what we're going to do is add on our period cut in half k. I'm going to show you now on the graph why that is. I'm going to prove to you. Okay. So here's my first asymptote. Here's my second, because that's according to my table, right? So I see that I am going a full, excuse me, I am going half a pi to get to my next one. This is a full pi right here, right? 4 pi over 4 added to 1 pi over 4 is 5 pi over 4. So as you can see, if this is pi, I'm having an asymptote every pi halves. So that's why we are adding pi halves k each time that we go. All right, next one. Let's do some secant. All right, x, y, we're going 0, pi over 2, pi, 3 pi over 4. Why did I do that again? 2 and 2 pi. Now let's keep in mind that cosecant is undefined. 1, undefined. -1, undefined. Okay, it looks like we're doing a vertical shift up of 2. So add 2 on. We get undefined 3, undefined 1, undefined. All right, it looks like we're not doing anything. It's still going to be 2 pi for the period, but we are going to go to the right, pi over 4. My pi looks like an H. I'm getting messy with my handwriting, guys. Pi over 4. So this becomes 3 pi over 4. Then 5 pi over 4. 8 pi. No, not 8. 7. 7 pi over 4. 9 pi over 4. Again, the period's 2 pi because we never change anything, and we can double check on that. So period, remember, is 2 pi over b. So we get 2 pi over 1, just 2 pi. So our asymptotes, right? Start at the most positive asymptote, which is pi over 4. Now we're going to add our period over 2k. So our period cut in half. Well, what's 2 pi cut in half? 2 pi cut in half is pi. Okay. And then we have our graph. We go pi over 4 to 9 pi over 4, and then I keep going. Luckily, as I can see, the pattern is we're still over 4s, and we're adding 2 pi to the numerator. Not 2 pi over 1, but just in the numerator itself. Having those patterns help you do the units quickly. All right, number 3 here, what we need to keep in mind is we need to factor first. So we're factoring out of 1/2. So if we factor out 1/2 times what is pi over 6? Pi over 3. Okay. So it looks like we're doing everything to our x values. And this is secant, so 0, pi over 2, pi, 3 pi over 2, 2 pi. We have 1 undefined, -1 undefined, and 1. Okay, let's deal with the period first. So we're going to multiply that by 2, right? 0 pi, 2 pi, 3 pi, 4 pi. Okay, so let's check on our period. Period is 2 pi over b, 2 pi over 1/2. Dividing by a fraction is the same as multiplying by its reciprocal, so we get 4 pi. And what do you know? 0 to 4 pi. We're good to go. We are moving to the left, pi over 3. So I get negative pi over 3. Do this math really quickly. 2 pi over 3, 5 pi over 3, 8 pi over 3, 11 pi over 3. Asymptote. What is our first positive asymptote? It looks like it's at 2 pi over 3 plus, okay, our period divided by 2. So 4 pi divided by 2 is 2 pi. Okay. Let's see what that looks like. Awesome. So again, that pattern there, my 3's are in the denominator, and it looks like I'm adding 3 to the numerators. One more and we're done. So this one I have to factor out again. I'm factoring in a pi over 4. So be careful right here. Pi over 4 times what is 3 pi over 4? 3. Okay. So we have our table. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now this is cosecant, so we get undefined, 1, undefined, -1, undefined. All right, so we got to remember that too. So we're doing this vertical stretch of 2, undefined, 2, undefined, -2, undefined. Let's do our period first. We're going to multiply by 4 over pi. I know that seems weird, but remember, some things cancel. So we get 0, 2, 4, 6, and 8. So let's check our period right now. Period is 2 pi over b. Dividing by a fraction, same thing as multiplying by the reciprocal, right? So when I do that, I get 8, and the pi's cancel. So what do you know? 0 to 8. We're good to go. And then we're going left 3. So -3, -1, 1, 3, and 5. Let's do our asymptotes. So our asymptotes, we want the first positive asymptote, which is at 1, plus, and then remember we're taking our period, dividing it in half, so that's 4. Okay. There's our graph. Oh, what did I do? I did it on here, but I didn't do it on this one, right? I needed to multiply by 2 here. You guys see what I did wrong on my graph? I didn't write on the lesson. There we go. And now I can make this work because I can go. Ta-da. All right, guys, do some practice. Watch out your graphing for the computer program. Mess around with it. See what works and what doesn't.